Dear students, today we are going to see non-flow processes. The processes occurring in a closed system which do not permit the transfer of mass across their boundaries are known as non-flow processes. It may be noted that in a non-flow processes, the energy crosses the system in the form of heat and work, but there is no mass flow into or out of the system. Types of non-flow processes. Reversible non-flow process, isochoric process or constant volume process, isobaric process or constant pressure process, isothermal process or constant temperature process, adiabatic process or isentropic process. Irreversible non-flow process, free expansion process. Isochoric process. An isochoric process, also called a constant volume process, an isovolumetric process or an isometric process is a thermodynamic process during which the volume of a closed system undergoing such a process remains constant. The isochoric process here should be a quasi-static process. It describes a behavior of gas inside the container that cannot be deformed. Since the volume remains constant, the heat transfer into or out of the system does not the PDV work, but only changes the internal energy of the system, that is temperature. In engineering internal combustion engines, isochoric processes are very important for their thermodynamic cycles. Example, Otto and diesel cycle. Therefore, the study of this process is crucial for automotive engineering. The change in internal energy and the change in enthalpy have the same expression for each process. During expansion or heating process, the work is done by the gas. Internal energy of the gas decreases and the heat supplied to the gas. During compression or cooling process, work is done on the gas. Internal energy of the gas increases and the heat supplied by the gas. Isobaric process. An isobaric process is a thermodynamic process in which the process of the system remains constant. That is, P equal to constant. The heat transfer into or out of the system does work, but also changes the internal energy of the system. Since there are changes in internal energy dU and changes in system volume del V, engineers often use enthalpy of the system, which is defined as H is equal to U plus PV. In many thermodynamic analysis, it is convenient to use enthalpy instead of internal energy, especially in first law of thermodynamics. In engineering, both important thermodynamic cycles, Brayton and Rankine cycle, are based on two isobaric processes. Therefore, the study of this process is crucial for power plants. When the gas is cooled at constant pressure, there will be a compression. The temperature and volume will increase during cooling and work is said to be done on the gas. During expansion or heating process, the work is done by the gas. Internal energy of the gas increases and the heat is supplied to the gas. During compression or cooling process, work is done on the gas, internal energy of the gas decreases and heat is rejected by the gas. Isothermal process, a process in which the temperature of the working substance remains constant during its expansion or compression, is called a constant temperature process or isothermal process. This will happen when the working substance remains in a perfect thermal contact with the surrounding, so that the heat sucked in or squeezed out is compressed exactly for the mechanical work done by the or on the gas respectively. An isothermal process is a thermodynamic process in which the temperature of the system remains constant, that is T equal to constant. So there is no change in internal energy, del U equal to 0. The heat transfer into or out of the system typically must happen at such a slow rate to continuously adjust to the temperature of the reservoir through heat exchange. In each of these states, the thermal equilibrium is maintained. In case n equal to 1 corresponds to an isothermal or constant temperature process for an ideal gas and a polytropic process. Adiabatic process. A process in which the working substance neither receives nor gives out of heat to its surrounding during its expansion or compression is called an adiabatic process. This will happen when the working substance remains thermally insulated so that no heat enters or leaves during the process. The system can be considered to be perfectly insulated. In an adiabatic process, the energy is transferred only as work. The assumption of no heat transfer is very important since we can use the adiabatic approximation only in very rapid process. There is not enough time for the transfer of energy as a heat takes place to or from the system in these rapid processes. In adiabatic process in which n equal to gamma and the system exchanges no heat with its surrounding, that is Q equal to 0, delta T not equal to 0. In an isothermal process, there is no change in internal energy and therefore del U equal to 0 for ideal gas and Q not equal to 0. An adiabatic process is not necessarily an isothermal process, nor is an isothermal process necessarily adiabatic. In real devices such as turbines, pumps and compressors, heat losses and losses in the combustion process occur. Still, these losses are usually low compared to overall energy flow and we can approximate some thermodynamic process by the adiabatic process. Isentropic process. An isentropic process is a thermodynamic process in which the entropy of fluid or gas remains constant. It means the isentropic process is a special case of an adiabatic process in which there is no transfer of heat or matter. It's a reversible adiabatic process. An isentropic process can also be called a constant entropy process. In engineering, such an idealized process is very useful for comparison with real processes. Polytropic process. A polytropic process is any thermodynamic process that can be expressed by the following equation. PV power n equal to constant. The polytropic process can describe gas expansion and compression, which include heat transfer. The exponent n is known as the polytropic index and it may be checked on any value from 0 to infinity depending on the particular process. Throttling process or isenthalpic process. A throttling process is a thermodynamic process in which the enthalpy of gas or medium remains constant. The throttling process is one of the isenthalpic process. During the throttling process, no work is done by or on the system and usually there is no heat transfer from or into the system. On the other, the throttling process cannot be isentropic. It is fundamentally irreversible process. Characteristics of throttling process: no work transfer, no heat transfer, irreversible process Isenthalpic process, throttling of the wet steam is also associated with the conservation of enthalpy. But in this case, a reduction in pressure causes an increase in vapor quality. Thank you.